Hello, everyone. This section is going to be section 6.2. Uh, Again, before I start the lecture, I just want to announce you guys about the homework one more time about of section 5.4, 5.5, and 6.1. So basically, the web assigned homework of these two, or basically you can say these three sections, but I have just divided these into two homework. Well, I covered these two lecture last week. All right, it was last week. So now, yeah, the homework for this one has to be due November 7. I see that some of you guys have already done it, but if you guys haven't done it yet, please finish it by this Saturday, November 7. Okay, which is this week Saturday. All right. Okay, now. Okay, now this is section 6.2, which is about exponential function. So when I say exponential function, probably you guys remember this term from algebra class. Okay, so the exponential function is a function where you can write this thing, this form, y is equals to b to the power x, where this b on the base, x is on the power, and this b on the base, this must be greater than 0, and b cannot be equals to 1. So that means if I say y is equals to 2 to the power x, then this is an exponential function, right? Because this base b is greater than 0, greater than 0, and this is not equals to 1. So this is an exponential function, right? And if I say y is equals to negative 2 to the power x, then okay, this is a negative number. So that means this is not an exponential function. All right. So I hope you guys learned this in algebra. All right. Anyway, now there is another one, another exponential function, y is equals to e to the power x. So e here, e on the base here is, well, in math, e means a number, some number. All right. So e is equals to 2.718, blah blah blah. It's a big number, all right, but this is a number, all right, and since e is 2.7, so this definitely satisfy this condition, right? It's greater than 0, it's not equals to 1, so I can even say this is an exponential function. And the e basically, it behaves, the function e behaves, I mean, it has a mathematical application. You can use this in math, or you can even use this. I see lots of examples in chemistry and lots of other fields in engineering too, and also in account area as well. But yeah, but it has some application. That's why a scientist or mathematician made this equation, all right, or made or introduced this term, all right. Anyway, so so since we are doing calculus, so we'll be focusing more on calculus stuff, all right. So which means we'll be focusing more on derivative, integration, and stuff like that, all right. So first, let's see the derivative, all right. So let's see the derivative. So when I say the derivative of exponential function, which means, okay, let's say if f of x is equals to e to the power x, e to the power x. So if I'm taking the derivative of this function, I can say f prime of x, right? If I'm taking the derivative of this function, e to the power x, and this function is in terms of x, so it will be e to the power x, all right. So it will be same thing. So the derivative of e to the power x is e to the power x, okay. Or even if I take the double derivative, it is still e to the power x. Okay. Now, what about if I have, let's say if I have equation f of x is equals to e to the power x square. So if you have now, if there is just x, then it will be e to the power x. The derivative of this will be e to the power x. Now, now I have x square on the power, right? So now in this case, we need to use, if you guys remember, uh, if you guys remember, I think it was in chapter 2, if I remember correct. Yes, I think it's chapter 2. But anyway, we did chain rule, right? So we need to use chain rule here. So basically this section, we are doing nothing new here, actually. It's just that this is a new thing here. We're just applying this new idea to the technique that we have already learned before. All right, nothing new here. Okay, so if I take the integration of this, okay, the first I have to take, sorry, let me say this one more time, not integration, this is derivative, f prime of x. So if I take the derivative of this, or first I have to take the derivative of this whole thing, right? So if I take the derivative of whole thing, or e, it will be e to the power x square, right? Times, now the derivative of, now I have to, after that, using chain rule, I have to take the derivative of x square. So if I take the derivative of x square, 2 will come down, and x to the power 2 minus 1, right? So which is e to the power x square 2x, right? Now, similarly, let's say if this is 1, then let's say 2, if y is equals to e to the power 4x times sine x. Okay, so now here, since we have two terms, now I can use product rule, right? So like I said before, there is nothing new here. There is just that we have new equation e, and we just need to apply this, or you can even say this is a formula. So we can apply this formula here. That's it. Okay, so now if I take the derivative of this one, I can even say, well, instead of writing like this, I can even write dy over dx like this, right? So the derivative of this one is, okay, so first I can take the derivative, I keep saying integration, since we're doing integration right now, so I keep saying integration. So, so e to the power 4x. So first, just like I did here, I take the derivative of this whole thing, e to the power 4x, and then using chain rule, take the derivative of 4x, which is just 4, right? And plus, now this will stay the same, and take the derivative of sine x. So the derivative of sine x is cosine x, right? I have to write bracket here. So cosine x. That's, I forgot to write. So let me write it again. So after this, when I take the derivative of this one, well, it's this, right? And then this will stay the same. I forgot to write this. Plus, now this will stay the same, and the derivative of sine x is cosine x. Okay, yeah, that's it. I mean, that's all you got to do here, right? Okay, so since I said that, since we're not learning any new technique here, it's just that we are using the same technique. It's just that we are using this new formula here. So you might see in the homework, you might see, well, this one we used product rule, right? And you might see an example with quotient rule. So the reason I'm not doing that is, well, I'm not doing all of these is that we have already done this. All right, we have already done this. There is nothing new here. It's just that we have a new formula. You just have to use that formula here. That's it. Okay, so that's what I'm saying. You might see the example similar to this, or whatever technique we learn, chain rule, product rule. What else we used? I don't remember. Uh, but yeah, but basically whatever technique we learned and uh, the derivative section, you might see that on the web assigned homework. All right. Okay, now let's go to integration. So since we said the derivative of e to the power x is e to the power x, so that means the integration of e to the power x dx, since we're taking the integration in terms of x, so this will still be e to the power x. Okay, so now since this is, well, we don't have the interval defined, so that means after this we need to write plus c, or plus constant, right? So we learned this. Now what about what about the integration of e to the power 2x dx? Okay, so when we take the derivative, we can use chain rule, but in the integration we cannot use the chain rule. So how are we gonna integrate something like this? Okay, so there is a technique here. So we can use this technique for different problems as well. So the technique we call a technique U substitution. Okay, so which means, so let me show you how I'm going to do this in this example, and I'll explain the technique in another example. Okay, so here what I can do here is, so I can, let's assume this thing on the top 2x, let's assume that as u. Okay, and u is equal to 2x. Okay, let's assume that. And then now let's take the derivative of this, or let's take the derivative of u in terms of x, du over dx, right? So this means I'm taking the derivative of this one. So the derivative of 2x is just 2. Okay, so what I'm doing is u substitution, means I'm basically changing all of these variables to u. Okay, so what I can do from this one is, if I multiply dx on both sides, then it will be du is equals to 2dx, right? So this dx will move here, right? Okay, so I assumed u is equals to 2x. I get no, sorry, I need to find dx, sorry, not du, dx. So well, from here I can now basically divide 2 on both sides. So 1 over 2 du is equals to dx, right? So what I get from here is that, now what I can do is that from now this equation, if I change this, well, this equation is in terms of x, so if I change this equation now to u, then I can say that this is equals to integration of e to the power, I assumed here that u is 2x, so u e to the power u, and dx, well, I said that the dx is this, right? Dx is 1 over 2 du. So I can replace dx by 1 over 2 du. Okay, now after this, since 1 over 2 is a number, right? So if you have a number, then I can just bring this out, right? So 1 over 2 integration of e to the power u du. All right, so now this is similar to this one. It's just that now we have u here, and we are taking the integration in terms of u. So that means it's just that 1 over 2. So the integration of this one is e to the power u plus a constant. There you go. And after this, since we're taking the integration which has x, now I can replace this back to u. So I know that 1 over 2 e to the power u is 2x. So here u is 2x, so 2x plus c. So 1/2 e to the power 2x plus c. So the integration of this one is this, right? So yeah, this technique we call use substitution technique. Okay, so now let's do another example. Let's do this one. X squared e to the power x to the power 3 dx. Okay, so now x squared times e to the power x to the power 3. X to the power 3 is in the power of this e. Okay, so now so when we use substitution here, again we are using use substitution. So when we're using use substitution, so what is u? How do we assume u? So what I can see from this one, well, since I have x squared, we didn't have anything here, right? We just had x terms on the power, that's it. Now we have this x squared. So what I can see is that if I take the derivative of x squared, I'll get x squared of, if I take the derivative of x cubed, then I'll get x squared terms, right? If I take the derivative of x cubed, then it will be 3 will come down and x squared, right? So I'll get x squared term. So so that means here in this case, now I can assume, so if you have something like this, then I can assume this term as u. So I can assume this whole thing on the power x cubed as u. Okay, then if I take the derivative of this du over dx, if I take the derivative of this d over is 3x, right? And then since I need, okay, so this one I can also write as e to the power x to the power 3 x squared dx, right? I'm just rearranging this to this. Okay, so now I can I need to find something that can be replaced for this. Okay, so well, this is x squared. So what I can get from this is, well, if I multiply dx on both sides, it will be du over 3x squared du is equals to 3x squared dex. Okay, so I'm trying to find something for x squared dx. Now I still have this 3, so divide 3 on both sides, so it will be 1 over 3 du x squared dx. All right, there you go. So x squared dx, I can replace this by 1 over 3 du. And here e to the power x cubed, well, I can replace x cubed by u, right? So that means, so I can say that it will be from here, it will be equals to, so it will be equals to integration of e to the power u, right? X cubed is u. And this whole thing, I'm replacing x squared dx by this 1 over 3 du. All right, so it's now similar to what we did here, right? So now I can move this one over, yeah, I can move this one over here. So 1 over 3 e to the power u du. So if I take the integration of e to the power u in terms of u, then it will be just e to the power u plus c constant, right? Now replace this back to x terms, so it will be 1 over 3 e to the power u is x to the power 3 plus c. All right, so yeah, this is the final answer of this. So the integration of this is this. Okay. So yeah, so here on the integration, you learn new technique, right? Use substitution technique. Okay. I will continue. Well, yeah, I think I'm done with this 6.2, but 6.3 is going to be logarithmic. So logarithmic function is somewhat related with the exponential function. Okay, so I'll talk about that on the next lecture. Okay, so this section was about exponential function. Okay, I'll talk more about probably about the exponential function as well on the next uh, lecture. But for right now, for this section for 6.2, this is it. All right. All right. Thank you.